My name's Richard Johnson and I'd like to give you a short presentation on how we can use spray drying to enhance the solubility of polysoluble drugs. Something like 50% of new chemical entities either in development or coming onto the market are classed as either insoluble or polysoluble. This creates a number of issues, particularly around the formulation, delivery and bioavailability of the new chemical entity. A number of techniques are now currently being used to try and overcome this problem of poor solubility. Some recent examples include the use of solubility enhancers such as cyclodextrins, nanomilling, which breaks up the drug into a small nano-sized particle to increase surface area, hot melt extrusion, and more recently spray drying and creating a spray dried dispersion to improve the solubility of polysoluble drugs. Spray dried dispersions, or SDDs, are now being used to enhance the solubility and bioavailability of polysoluble drugs. This is achieved by spray drying both the drug and the polymer from an organic solvent, and this is usually done in an inert atmosphere to avoid the risk of flammability and explosion. The resulting powder that's produced from this process will consist of a drug dispersed intimately at a molecular level in a polymer matrix. Both the drug and the polymer under these conditions are amorphous rather than crystalline, but once the spray dried dispersion is placed back into water, the polymer will quickly dissolve, and when the polymer dissolves, the drug in a nanoform will be dispersed into the aqueous environment, and the result is a nanodispersion of drug in the aqueous environment. As a result, the drug will have a huge increase in its surface area, and with it an increase in solubility and bioavailability. Here's a simple diagram showing you how the spray dried dispersion is created. We start with the polysoluble drug and the polymer. Both of these are dissolved in an organic solvent to produce a drug polymer solution. This drug polymer solution is then spray dried, and the spray dried powder consists of a spray dried dispersion of the drug mixed intimately with the polymer. When the spray dried dispersion is placed back into water, the polymer dissolves it virtually instantly and the drug is released as a nano suspension, with a subsequent increase in dissolution and ultimately bioavailability of the drug. When we're developing a spray dried dispersion, there are a number of key variables that we need to evaluate. The first of these is the choice of solvents. We need to find an organic solvent that has good solubility properties both for the drug and the polymer. We also need to avoid the presence of any crystallization occurring at any point during the process. If crystalline drug is present, this can ultimately lead to instability of the spray dried dispersion. So quite often it's quite usual to filter the drug polymer solution before we spray dry to remove any traces of crystalline drug. The second aspect we need to evaluate is the choice of polymer and the drug to polymer ratio. We need to evaluate a range of different classes of polymer. Polymers of different charge will have different interactions with the drug, so we need to screen a number of polymers before we arrive at the best polymer for that particular drug. If the polymer drug spray dried dispersion doesn't give us the properties that we require, it may be necessary to add a surfactant into the spray drying process to improve the solubility further. And finally, the spray drying conditions themselves that we use to create the spray dried dispersion will also have an impact on how the spray dried dispersion performs in the aqueous environment. We need to evaluate, for example, the speed of drying, the temperatures that we use, because these can affect the amorphous and crystalline content or the amorphous and crystalline ratio of the spray dried powder, and also the residual solvent levels. Here are some examples of some of the most widely used excipients that were used to create spray dried dispersions. There's the family of polyvinyl pyrrolidone and some of its derivatives such as PVP, PVPVA, hydroxypropyl methyl cellulose and some of its derivatives like HPMC and HPMCAS, polyacrylate and some of its derivatives like the eudragites. Also, here's some examples of different solvents that we can use to create a spray dried dispersion. Obviously solvents like methanol and ethanol are widely used, as are acetone, and also some chlorinated solvents, although the pharmaceutical industry tends to look at these unfavourably. The first part in formulation development is usually a solvent screening test where we look at the solubility of the drug in a number of different organic solvents until we find a solvent with good levels of solubility for the drug in question. We can then spray dry the drug and the drug with a number of different polymers to produce some initial formulations. We call this polymer screening. And then once we've chosen the best polymer for the drug that we're working with, we can optimize the drug to polymer ratio. And finally, if necessary, if the dissolution of the drug is still poor or the nanosuspension is unstable, we can look at the addition of surfactants. At the same time that we produce these test formulations, it's also important to do a number of physical tests to ensure that the spray dry dispersion is both amorphous, stable, and also that it has good dissolution properties. So for example, we use a number of physical tests such as DSC and XRD to ensure that the spray dry dispersion is completely amorphous with no crystalline contents. We also look at the in vitro properties of the spray dry dispersions, looking at in vitro dissolution under a range of different conditions to ensure that the spray dry dispersion has good dissolution properties. We'll also put a number of our test formulations onto a small stability trial to ensure that the spray dry dispersion is stable under normal storage conditions. Here's an example of some work we did in the laboratory using ibuprofen as a test molecule. As you know, ibuprofen is relatively insoluble in water. However, if we spray dry ibuprofen in methanol with a polymer such as Collinone VA64, we find that we can produce a spray dry dispersion with good dissolution properties. In this case, we found that the ratio of polymer to drug was optimal at around 75 to 25, so 3 parts polymer to 1 part drug in the spray dried powder. The resulting spray dried powder was found to be amorphous with no sign of any crystalline ibuprofen present in the spray dried dispersion, and that this spray dried dispersion then had excellent dissolution properties when we went back into water. Here you see an XRPD trace of ibuprofen as it's supplied as a crystalline product. See the clear peaks. However, the X-ray pattern of the spray dried dispersion of ibuprofen and Collinone shows the complete disappearance of any crystalline ibuprofen in the spray dried dispersion formulation. What happens when the spray dried dispersion is placed in water? Well, you can see from the pink line, the drug itself, the crystalline ibuprofen, is relatively insoluble in water, showing very low levels of dissolution over a series of minutes. However, the spray dried dispersion of ibuprofen and Collinone shows a much improved dissolution profile in an aqueous environment, as you can see from the blue curve. For the second example, I'd like to use a drug called torcetrapib, and this is from some data published by Friesen et al. In 2008. Torcetrapib as a drug has relatively poor aqueous solubility in the crystalline form. It has poor solubility and as a result has poor bioavailability. It has a relatively low glass transition point of about 29 degrees C, so when it's in the amorphous state it's relatively unstable. However, we can overcome this by producing a spray dried dispersion. When the drug is dissolved in an organic solvent, in this case methanol, the drug was dissolved with a polymer, in this case hydroxypropyl methyl cellulose acetate succinate, or HPMCAS. This is an interesting polymer that has both hydrophilic and hydrophobic regions along its length. It also has a high glass transition point at 119 degrees C. When we spray dry torcetrapib with HPMCAS, we produce a spray dried dispersion. Friesen and his group found that the best ratio of drug to polymer was 25 to 75, so again a 3-to-1 ratio of drug to polymer. This gave the best dissolution properties, but also gave us a high glass transition point, actually an intermediate glass transition point between the drug and the polymer. So we had a glass transition of 82 degrees C for this spray dried dispersion, and this results in excellent room temperature stability. What the investigators also found were that the drug and the polymer in the spray-dried dispersion were in the amorphous state. When the spray-dried dispersion is placed in water, it showed excellent dissolution properties. The polymer dissolved rapidly to release the drug in the nanoform. As you can see here, the pink line shows the dissolution profile of crystalline torcetrapib. What Friesen found with his spray-dried dispersion is that in the amorphous form, the torcetrapib HPMCAS spray-dried dispersion had excellent solubility profile. Not only did it show excellent solubility profile, it also showed much increased bioavailability. You can see in the blue bar on the left, the crystalline drug has relatively low in vivo blood levels, but the same drug formulated as a spray-dried dispersion shows a huge increase in uptake and blood levels. So finally, in conclusion, I'd like to confirm that spray drying is now being widely used to enhance the solubility and bioavailability of poorly soluble drugs. This is achieved by creating a spray-dried dispersion of the drug in a water-soluble polymer. When you're creating your spray-dried dispersion, it's important to evaluate a number of key variables. For example, the choice of solvent, the choice of polymer, and the polymer to drug ratio, and also the spray drying conditions that you use. The result of these studies should be a spray-dried dispersion of your drug which has both a good stability profile and ultimately a significantly improved dissolution and bioavailability profile. Thank you very much for listening to this presentation. If you'd like to discuss the use of spray drying to formulate your poorly soluble drug, please do not hesitate to contact me at the website or via my email, which is produced here, or via the telephone. Thank you very much for listening.